Alright, today we're looking at Objective 61, which is factoring quadratics. So we're continuing our journey into factoring. Let's start off with some review. Here we've got a binomial times a binomial. Remember to multiply these out, we use a process that we call FOIL, which stands for first, outer, inner, last. So this tells us the order by which we multiply the terms. So we start with the first terms. We have x times x gives us x squared. We do the outer terms, so we have x times negative 6 gives us a negative 6x. We do the inner terms, so 4 times x gives us a positive 4x. And then last we have positive 4 times negative 6 gives us a negative 24. We combine like terms. I see some like terms here, so we have x squared, a negative 6x plus a positive 4x gives us a negative 2x minus 24. Next up, we'll FOIL this, so we have y times y is y squared. Outer, so 5 times y is 5y. Inner, 3 times y, so we have 3y. And last, 3 times 5 gives us 15. We combine like terms. I see a 5y and a 3y, so this would be 8y plus 15. And then last we've got first terms, so z times z gives us z squared. Z times negative 8 gives us a negative 8z. Inner, we have negative 4 times z gives us a negative 4z. And last, we have negative 4 times negative 8 gives us a positive 32. Combining like terms, we have a negative 8 and a negative 4 gives us a negative 12z. So we have this here. So why is this important? We studied this a few units ago. This is important because we are multiplying these out. We're distributing each of the terms. Remember, factoring is reverse distribution. So what our goal is for the end of the day today is we want to start here and we want to factor it into these terms here, these factors here. So we want to go from here to here. We want to go in the reverse direction. So here, again, this is a polynomial of degree 2, so this is a quadratic. So today we're going to be talking about factoring quadratics. So we're going to have a term like this, and we're going to go in reverse, and we're going to find its factors. So the first thing that I want to note is the general form for a quadratic expression is, so we've got a number, we'll call that number a, times x squared plus another number, so a different number, times b, or times x, so we'll call that number b times x, and then plus a number at the end, so that's just a number, there's no x attached to that. So we have ax squared plus bx plus c, so we've got an x squared term, an x term, and just a constant, just a number. Okay. So looking at this here, here we have 3 terms. That number out in front of x squared is 1. Remember, it's not written. The number out in front here, our b term, would be 8. And then that number just attached on at the end is plus 12. That's our constant. In order to factor, this is the second thing, we want to find the numbers that multiply to c. So again, c is just that number that's attached at the end. So looking at this one here, that number is 12. So what numbers multiply to 12? Well, 1 and 12 do. What else? 2 and 6, or 3 and 4. Those are all the factors of 12. So those are all the numbers that multiply to get to this third number here. Step 3, we want to choose the pair, so the pair of factors, the pair of numbers, that adds or subtracts to b. And again, b is that, you can put this in parentheses, b is that middle number. So in this case here, in this example, we want one of these pairs to add or subtract to 8, that middle number. So is there a way that we can add or subtract 1 and 12 to get to 8? No, let's see. 1 plus 12 is 13. 12 minus 1, 11. No, we can't use that and ever get to 8. What about 3 and 4? So we could add them. We get 7. We subtract, we can get 1 or negative 1. It's not that. 2 and 6, we can try that. So 2 plus 6, that gives us 8. So this is our pair of terms that we're going to be using. And in particular, how do we get from 2 and 6 to 8? Well, we take positive 2 and we add it to positive 6. So when we're writing this, it's always going to be in the form. So I'll say always factor as x plus a number times x minus a number. This is just, these pluses can be minus. They can be both positive, they can be both negative, they can be positive, negative, positive. They can be any combination. As long as you have an x plus or minus a number times x plus or minus another number. Okay, so in this one here are our numbers. We have a positive 2 and a positive 6. When we factor it, it's going to be x plus 2 and x plus 6. So this is our factored form of this quadratic here. If we were to FOIL this out, we would get back to this. If we were to FOIL this, we should get back to here. So let's go back and let's check and see. So FOIL, first term is x times x. Outer, 6 times x is 6x. Inner, 2 times x is 2x. And last, 2 times 6 is positive 12. Combined like terms, we have x squared. 6x and 2x does give us our 8x. And then plus 12. So this checks out. We do have the right solution. So this is the factored form of this quadratic here. So let's try a few examples here. I'm looking at this. It's in the form already. It's got a squared and then minus 9a minus 10. It's already in that general form. So we look at this third number, this c term, this negative 10. So what numbers multiply to get to 10? Well, 1 and 10, or 2 and 5. And then we look, what pair of those numbers, so we want to choose a pair that adds up to that middle term, that negative 9. So can 2 and 5 ever add up to negative 9? Let's see. 2 plus 5 is 7. 5 minus 2. No, that doesn't ever give us a negative 9. But let's try 1 and 10. So 1 plus 10 is 11, but maybe 10 minus 1, that gives us a positive 9. But what about like a positive 1 and a negative 10? A positive 1 and a negative 10 does give us our negative 9. Okay, so again, the sign, it's got to be negative 9. So then our factors are a plus 1 and a minus 10. And you can go back and double check, FOIL this out, and see if you get this. Let's try another. So here we have b squared minus 7b plus 12. We want to know what numbers multiply to 12. So we have 1 and 12, 2 and 6, 3 and 4, and that's it. So any of these pairs that add up to negative 7, let's see, 1 and 12, no, that's not going to do it. 2 and 6 gets us close. We could hit 8, but not negative 7. So we can't do that one. 3 and 4, let's see. We could do a negative 3 and a negative 4, and that would give us a negative 7. So we have b minus 3 and a b minus 4. All right. Let's try this one. Here we have 27 as our last term. So what numbers multiply to get to 27? We have 1 and 27. 2 doesn't work. 3, 4, 5, 6. 3 works, sorry. 3 works with 9. Let's see, and that's it. So we have 1 and 27, 3 and 9. Let's see, we want to add up to positive 6. 1 and 27 isn't going to do that. So 3 and 9. Let's see, we could do positive 9 and minus 3. So 9 minus 3. That'll do it. So we have c minus 3, and we have a c plus 9. And that works. Some students ask if you can flip these around. So if you have c plus 9 times c minus 3, so like this, so c plus 9, c minus 3. Yes, you can flip those around. These are the same. As long as you keep your positive with your 9 and your negative with your 3, so as long as your signs they stick with the right numbers, that's fine. These are the same. So you can switch these around. We're going to get a whole lot of practice on this. This is Factoring Quadratics, Objective 61.